Hi, today is a big day because not only do we get to use the power rule that we were using before, but you get to learn a new rule for taking the derivative. Do, 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 do. I didn't even plan that dance. You thought she probably choreographed that before, but no, it just came out of nowhere. So if you were doing this dance, do, 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 because you were really happy too, we have so much in common. Let's do this. So this one says rewrite this function, and it's this big mess, as a cubic function. So I'm just expanding this so that it looks like a polynomial. I'm getting a little bit darker marker. So I'm going to say f of x, then I'll distribute this. So you could do this too, and then we could see if we have the same thing. This would be 2x to the third power minus 4x squared plus 2x minus 3x squared. So I'm taking this through. Plus 6x minus 3. And then I can combine like terms. So I have 2x cubed minus 7x squared. 2x and 6x is 8x minus 3. And just because I can, because I've done this before, 2x cubed minus 7x squared plus 8x minus 3. I checked this was past me because I already did this once before. So guess what? We got the right answer. Well, at least I got the same thing now in present me as old me. Or would I be old me? Because I'm technically in the future from that. Who's older? I don't know. Questions of the world. Okay, so now I have this as f of x. And I want to find f prime of x. So I take 3 times 2, and I get 6x squared, because I'm subtracting 3 minus 1, minus 7 times 2 is 14. X, this would be to the first power, so I can just write 14x, plus 8. The slope of 8x is just 8. Minus 3 would be the derivative of negative 3 would be 0. So this is my slope, and again, what does f prime of x represent? The slope of the tangent. F prime of x is the slope of the tangent, and we can say of f of x. And this is for any point x, but this is good. Okay, so why am I telling you this? What are we doing? Well, if you read the next part, it says 2 men, Isaac Newton and Gottfried Leibniz. That is an impressive name. So I'm hoping that someone has a grandparent, like a grandfather or something, with the name of Gottfried. Let me know if you do, because I feel like you've got some really good opportunities to, I don't know, for Halloween costumes and stuff. Not that you have to have the same name as your Halloween costume, but whatever. Okay, but 2 people are credited for developing the study of calculus. In 1673, Leibniz published an article in which he derived what we knew today as the product rule of differentiation. So 2 different people came up with calculus, but they've developed each parts of it. What he came up with was this. And I'm going to leave this here for a second, and you can pause the video so you can write this down. But it says the product rule of 2 differentiable functions. So differentiable just means that I'm able to take the derivative. And we're going to talk about what that is more later, but differentiable just means you're able to take the derivative. U and V. So this is the letter U and the letter V. The product of a differentiable function U and a differentiable function V, product means the answer to a multiplication problem, so we're multiplying these together, is differentiable, meaning you can take the derivative. And what this means is the derivative, this is d dx, this is this is Leibniz notation, d dx of uv, so the derivative of uv is u times the derivative of v, so this dv dx, it's like, you know how rise over run, the change in y over the change in x, this is the same idea, change in v over change in x, plus v times du dx. But most of the time when I say this, if I have the derivative of first times the second, what you do is you take the first term, the first whatever it is, times the derivative of the second, plus the second times the derivative of the first. And I will say this over and over and over again, and you'll memorize it too. First times the derivative of the second plus second derivative of the first. This is the product rule. So let's actually try to use this now. To show that this works, let's apply this rule to this function. And you can see that it's actually the same function that we had up here. Isn't that nice? Except this time, I'm not going to multiply this out first. I'm just going to take the derivative. And I'm going to say this is the first part of my function. The 2x minus 3 is a function in itself. So 2x minus 3 is my u, or in this one, I'm going to say my first function, times a second function. This is my v, or I can just say this is my second function. So to find the derivative, I'm going to go over here, make sure that you're labeling clearly. F prime of x is the first. So I'm going to write 2x minus 3 times the derivative of the second. So I'm taking the derivative of this thing, and I would get 2x minus 2 plus the second, so this whole term, x squared minus 2x plus 1, times the derivative of the first, 2. You might say, that doesn't look like what we got before, but let's actually simplify this so you can be convinced. F prime of x, that would mean 2x times 2x, I would get 4x squared minus 4x minus 6x, and you can do this on your own too, plus 6, so I just was distributing each of those terms, plus distributing this 2 through, 2x squared minus 4x plus 2, combine like terms, 4x squared and 2x squared, it would be 6x squared, negative 4x, negative 6x, negative 4x will be negative 10x, negative 14x. Did I mess up something here? Let me see. Oh wait, no I didn't, because I can see up above. That's what I'm supposed to get. This is negative 14x. 6 plus 2 is 8. And look at that. What? Woo! Woo woo! That's the same thing. You might say, why would I want to do that? Because there's sometimes when I can't actually multiply out and use the power rule, or it's just really gross to do so. So something that might look like this. So in this problem, I say g of x is equal to x squared times sine of x. And the rest of this problem said, this one says, in the case of a function like x squared sine of x, so this one, there's no way to rewrite this as polynomial. So we can't do the power rule on it, even if we try. So we need some other way. And the other way that we have is the product rule. This says, apply the product rule to find the slope of the normal line. What? Slope of the normal line? What's that? Remember, the slope of the normal line is the perpendicular, or I should say, the normal line is perpendicular to the tangent line. So the slope of the normal line is the opposite reciprocal of the slope of the tangent line. Slope of the tangent is the derivative. So pretty much every problem, whenever you see this, you're like, what do I do? I take the derivative, and then you have to do something with it. So if g of x is x squared times sine of x, make sure you're labeling, you're not just writing something down. This is going to be my first, this is my second. G prime of x will be first times the derivative of the second plus my second times my derivative of my first. So I did first, the derivative of sine is cosine, plus the second, that was sine of x, times the derivative of the first. That would be 2x. This says that x equals pi, so g prime of pi. I would get pi squared times cosine of pi plus sine of pi, 2 pi. Still going, g prime of pi would be pi squared. I'm not going to simplify this. I'm not going to make this into a decimal. I'll just keep pi squared. Cosine of pi, I would write something like this. Pi would be right here, halfway between 0 and 2 pi. So this is negative 1. Plus sine of pi. Sine curve in my mind looks like that. Sine of pi would be 0 times 2 pi. So if I simplify this one more time, I would get negative pi squared. This is the slope of the tangent. Then the slope of the normal line is the opposite reciprocal. So if this is negative, I would make it positive, 1 over pi squared. Ta-da! Look how pretty that looks. I mean, not my rectangle, but everything else looks so pretty. Did you hear that? Oh, it was you. It was you saying you wanted more. No problem. Let's do this. Let's practice. Okay, so you get actually a whole page of practicing here. So what you should do is as soon as you feel comfortable, just start on it. It says use the product rule to find the derivative of each of the following functions. You do not have to simplify in the end. So I would just say, sorry, I keep getting calls. I'm good. I'm very popular. You do not have to simplify. You just have to do the product rule. So as soon as you feel comfortable, go off into your own, and I'll check you at the end of each one. I'm going to do this one, and this one, this, and this. Ready? You go. And if you're still with me, I'm going to say this is the first. So 2x squared plus 3x times the derivative of the second. So the derivative of x squared minus 3 is 2x plus the second times the derivative of the first. So I would have 4x plus 3. Ta-da! And then you can leave it like that. I know, it's so exciting. This one, I would rewrite only slightly. Square root of x is the same thing as x to the 1/2. X squared minus 3x plus 2. Because this is only one term, this is actually pretty easy to distribute and then use the power rule, but whatever. I'm going to go with the product rule because I just did this. And notice how I am labeling. This is g of x, this is g prime. Be really careful about your labels. This would be my first term, or my first function, times the derivative of the second, plus the second times the derivative of the first. It's 1/2 x to the negative 1/2 power. Remember, you're taking the exponent times the coefficient, subtract 1 from the exponent. The only thing I'm going to simplify is I could change this back into square root of x if I wanted. You don't have to. But I do want to rewrite this as x squared minus 3x plus 2. Write that in the numerator. 1/2 would mean the 2 was in the denominator. And write the square root of x down here. Next one, f prime of x. This is a product, so I get to use the product rule. I'm going to say first times the derivative of the second plus the second times the derivative of the first. Hooray! Keep going. My first. So again, I would underline this, make sure that you've got this, that you're going to have a first function and then a second function. So I say first times the derivative of the second. The derivative of cosine is negative sign. Make sure that you have parentheses so it doesn't look like minus sign. So first times the derivative of the second plus the second times the derivative of the first, which is just 3. Okay, so everything's going swimmingly. And then down here, you might be like, what just happened? What do I do? There's a couple different ways to do this one, but g prime of x, you might be looking at this and saying, oh, there's two product rules. Here's a 3 times a theta. So you do first times the derivative of the second plus second derivative of the first. But what's the derivative of 3? It's 0. And so even if you tried to do the product rule on that, you could just say the derivative of 3 theta, just like the slope of 3x is just 3, you can write 3. Plus, here is where the product rule comes into play. This says plus, so we don't use it yet. This. So this is my first, theta is my first function, sine of theta is my second function. So I would say first times the derivative of the second plus the second times the derivative of the first. The derivative of theta, just like the derivative of x, would just be 1. So it's just 1. Over here, I've got sine of x, cosine of x. So you should be saying to yourself, first times the derivative of the second. The derivative of cosine is negative sine plus the second, cosine of x, times the derivative of the first, cosine of x. And you could leave it like that, but it's hard for me to just leave that here when I could say negative sine squared, so sine of x squared plus cosine of x squared. So you could write it like that and then leave it like that, which almost looks like it's a Pythagorean identity, but it's not because it would be this plus this. So not quite. Find the equation of the line tangent. It's like coming back to an old friend. To find the equation of the line tangent, you need two things. What are they? A slope and a point. So to find the slope of a tangent line, you need the derivative, g prime of t. Who did t's in here? Who's your teacher? T's are annoying to write with. You'd write first times the derivative of the second. The derivative of cosine is negative sine plus the second times the derivative of the first. You find this value at pi over 6. So g prime of pi over 6. Pi over 6 squared would just be pi squared over 6 squared. I'm going to make this negative right here because I've got a negative sine t. Sine of pi over 6 plus cosine pi over 6 times 2 times pi over 6. Whew, this looks gross. Take a minute and make sure that you've got this and that you're like, yeah, I feel pretty comfortable with this. I can do that. This is one where if you're not using point and slope form yet, if you're still writing in y equals mx plus b, you're going to want to stop because this is disgusting or awesome, however you want to think about this. G prime of pi over 6. If you say pi over 6, in this one, you can use triangles, you can use the unit circle, whatever you need to, but this would be still negative pi squared over 36 times 1/2 plus cosine of pi over 6. It's funny, I knew these and I still have to check myself to make sure. If you saw my eyes wandering, because I checked to make sure I've got this anytime that I haven't written down a triangle somewhere. Pi over 6 times 2 would be pi over 3. I don't want to mess with this because if I do, I'm probably going to mess something up. So I'm going to put parentheses around this entire thing, and this is now my slope. But I still need a point. G of pi over 6 is going to be pi over 6 squared, so pi squared over 6 squared, we said was 36, because pi squared, 6 squared, times cosine of pi over 6. So that's pi squared over 36 times the square root of 3 over 2. Look at this. You're going to have so many friends if you don't already, if you haven't already been showing them your math. This is a good time. Y minus, this is my y1. So I would, if you want to take 36 times 2, you can, but you don't need to. I'm going to say pi squared, square root of 3. 36 times 2, oh, do I want to? Sure, 72. I can put it together that much. Is equal to m, that disgusting thing, which you could put together more if you wanted, but I don't want to. So I would get negative pi squared over 36 times 1/2. Oh, I could have put that over 72, and that would have been fine. Plus square root of 3 over 2 pi over 3. That's all that. X minus my x1, which is pi over 6. Beautiful. So nice. Okay, and let's move on from that one. It really is pretty though. Look at it closely. Oh, look how pretty. Okay, next. This is on page 74. We're finishing up on this page. We're given this function, find f prime of x by applying the product rule. So I'm going to do that. So f prime of x is equal to, and this one, actually, didn't we do this one, did we do this one on the previous page? Oh, so close. Do you see this one over here? So very close. But we're going to do the product rule. So I'm going to say, first, times the derivative of the second. The derivative of the second is 2x minus 2 plus the second times the derivative of the first. So remember this one was square root of x, which is the same thing as x to the 1/2. So we can write 1/2 x to the negative 1/2 as my derivative. I'm going to keep going and I'm going to actually simplify this. So these are all equal. This is the same thing as x to the 1/2 power times 2x minus 2. I'll put that together soon. This, I already have an x to the negative 1/2, so I'm actually going to distribute this right now. Do I want to? Yeah, I do. So I'm going to say this is 1/2 x. Remember that you can add exponents together, so 2 minus 1/2. That'd be like 4/2 minus 1/2 would be 3/2. Minus, here it would become x to the 1/2 times x to the negative 1/2. I would add the exponents together. I would get x to the 1/2 power plus 3/2 x to the negative 1/2 power. I'm almost done simplifying this as much as I want to. So 2x, I'm going to add these exponents, so 2x to the 3/2 power minus 2x to the 1/2 power. And then I'm adding all this other business that I got before. This is a negative exponent, I don't like that. So 3/2 x to the 1/2 power. Okay, so for right now, I'm going to leave it like that, and then I'm going to go over here, and I'm going to say, you know what, I'm going to simplify this one and write it like a polynomial first. So f of x is equal to x to the 1/2, x squared minus 2x plus 3. Before I do anything, before I actually take the derivative, I'm going to keep this as f of x. So I'm going to say f of x again, just to be abundantly clear what I'm doing. And you could do that over here and say this is f prime of x each time. Just to be abundantly clear that this is what I'm finding right now. If I multiply x to the 1/2 times 2, I would get x to the 2 plus 1/2. So this would be 4/2 plus 1/2, 5/2. Minus 2x to the 3/2. I'm adding these together, plus 3x to the 1/2. Now I take the derivative, f prime of x. 5/2x. Subtract 1 from my exponent, 5/2 minus, this would be to the 3/2. Minus 3/2 times negative 2 would be negative 3. X, subtract 1 from the exponent, 1/2, plus 3/2 x to the negative 1/2. Simplify this just a little bit, 5/2 x to the 3/2 minus 3x to the 1/2 plus 3/2 x to the 1/2. That looks familiar. So that's the same right here. Sorry, I'm kind of writing this where my head is. These two things look familiar. These ones I'm like, not so much, but maybe, what if I simplified a little bit? This and this together. 2.5 is the same thing as 5/2 x to the 3/2. If I combine my terms, I've got negative 2x to the 1/2, negative 1x to the 1/2, which would be negative 3x to the 1/2. Hey, it's the same. Plus 3/2 x to the 1/2. All of this, the reason why I'm doing all of this is to show you that it doesn't matter which way you do this. You can wind up with the same answer. So the power rule and the product rule, when done correctly, obviously, will produce the same result. There are going to be times where you can only do the product rule, and you would have to use the power rule within it. So it's really important for you to know what the power rule is. But there are going to be times where you have to use the product rule. So it's not like you can avoid it, but there's times where you get a choice. Okay, down here it says, what's the slope of the normal line? So to do this one, you can see there's a product, but it's three things. It's like UV times W if I was making this other letters. So we actually have to do a little bit of work here first. The way that I would do this is that I would multiply something together. It doesn't matter what it is. This can be the first term and the second term, and you can find the derivative that way. Or you know what, I could say, this thing, I want it all to be one term instead. Because in order to get it to a place where there's a product rule, it needs to be only one function times another function. You can't have three. So x minus 1, x plus 3. If I multiply these together, I would get x times x is x squared, plus 3x minus 1x would be plus 2x minus 3. And I could multiply these out, but it's a good chance that I'm going to mess up something. So from here on out, I think it would be easier to take the product rule. So I'm going to say this is my first function, this is my second function. First times the derivative of the second plus the second times the derivative of the first. 2x plus 3 would just be 2. And then it says find the slope of the normal line, which means you just really find the slope of the tangent line and then take the opposite reciprocal. The slope of the tangent line is going to be g prime of 2. And you don't need to simplify. You can automatically substitute in x is equal to 2. So you could get 2 times 2 plus 3, 2 times 2 plus 2, plus 2 squared is 4, plus 2 times 2 is 4 minus 3. I got lazy. If you multiply all these things out, you would get 2 times 2 is 4 plus 3 is 7. 4 plus 2 is 6, so 7 times 6 is 42. Plus 4 plus 4 is 8, minus 3 is 5, times 2 is 10. 42 plus 10 is 52. This is the slope of the tangent line, because that was g prime of 2. So what is the slope of my normal line? That'd be negative 1 over 52. We did it! Air 5. That was an air 10. Hope I didn't hit you in the face. Thanks for working. You're great. And I appreciate you. Bye. Let me know if you have any questions.